Hello, everyone. We're working through an introduction to statistical methods and data analysis by Ott and Longnecker, Chapter 12, Part 5, Multiple Linear Regression, Qualitative, Independent Variables, and Interaction Terms. All right, suppose we have an example where the automobile insurance claim amount of college students is given by Y. X1 is the number of years since licensed, X2 is gender, and X3 is the car type. So we're going to set up X2. Dummy variable is somewhat of an outdated term. We're going to use the word indicator variable. We're going to set up X2 as an indicator where X2 equals 1 if you're male and X2 equals 0 if you're female, other, declined state. Okay. We're going to set up car type as an indicator variable as well. And we can do this in two different ways. Option one would be to create a variable X3 where it had three different levels. 0 is an American-made car, 1 is an Asian-made car, and 2 is a European car. The other way we could do this is create two variables, X4 and X5, where X4 is an Asian-made car and 0 else. X5 is a European-made car and 0 else. So the American car will be represented when X4 equals 0 and X5 equals 0. So that's really up to you. Let's talk about a few different situations. So in X2, if we thought about a model with no interaction terms, then that would be saying that we have parallel lines, right? So if we did a profile plot of the males versus everyone else, okay? Then if we don't have an interaction between X1 and X2, that would mean that these lines will look parallel when we plotted Y versus X1. So if we plot the line for the males and we plot the line for everyone else, we should have parallel lines, right? And if we write out the expected value for each of these groups, so for the males, right, X2 will equal 1. So we have the expected value of Y is equal to beta 0 plus beta 1 X1 plus beta 2, right? And for everyone else, we get the expected value of Y equals beta 0 plus beta 1 X1, right? So in this case, we can rearrange this first equation to be beta 0 plus beta 2 plus beta 1 X1. So what this is saying is that both groups have the same exact slope, right? They have the same exact beta 1, right? But the real difference is their intercept, right? For the group of males, their intercept is beta 0 plus beta 2. And for everyone else in our study, the intercept is just beta 0. So in this case, they both have an intercept and a slope, but both groups have the same slope. That means there's no interaction term, right? So if we want to interpret the slope coefficient for gender, right, the way that we're doing this is by saying, if we compare males to everyone else, right? Then we would predict that the automobile insurance would be beta hat $2 more on average for a known number of years licensed for driving. So what does this mean? If we compare these two groups of people and we hold the number of years of license constant, right? So suppose we're at a particular number of years constant, then the distance between males and everyone else is going to be a beta hat 2 difference, right? Okay. If we have an interaction term, that means that as x1 increases, right, then the lines cross, right? So essentially here we have an interaction between gender and the number of years since licensed, right? So we say that the effective gender depends on the value of x1, because if we have a smaller value of x1, this distance is a particular size, but at some point they're equal to each other, and at some point it switches which group is higher. So if you do a profile plot with x1 and y, and then you have one plot for x2 equals 1, and the other plot for x2 equals 0. If these lines cross, this means that you should have an interaction term. Okay. That's how you're going to be able to tell. So if we write this out, then all of a sudden, when we write out our equations, right? So for males, take the whole equation. The expected value of y is equal to beta 0 plus beta 1 x1. When you're a male, this indicator value equals 1. So plus beta 2 times 1 plus beta 3 x1 times 1, right? So rearranging this, we get beta 0 plus beta 2, right? Plus beta 1 plus beta 3 x1. All right, for everyone else, we get the expected value of y is equal to beta 0 plus beta 1 x1 plus beta 2 times 0, because now the indicator value is you are not a male or you decline to state. Plus beta 3 x1 times 0. So when I rearrange this, I get beta 0 plus beta 1 x1. So if we take the difference between these two groups, right? So take the difference, right? So we get beta 0 plus beta 2 plus beta 1 plus beta 3 x1 minus beta 0 plus beta 1 x1, right? And you take this difference, beta 0 minus beta 0 is 0. We're left with beta 2. Beta 1 x1 minus beta x1 plus beta 3 x1. So the difference between the two groups is now dependent on the value of x1. That's how you know you have an interaction term, right? So if the difference between the groups depends on the value of x, you have effect modification, right? So essentially, to interpret the effect, right, of x1, we need to do this separately for the males and the females, because for the males, the effect is beta 1 plus beta 3, right? They have a particular slope. But for everyone else who are not male, now the slope for x1 is beta 1. So essentially, if you're going to interpret the effect of x1 and you have an interaction term, you're going to end up needing to do this separately for each of the groups. And you'll know is when you take the difference between these two groups, the difference is going to depend on the value of x1, right? So we would have to say the difference between these two groups at this value of x1 is 5, but at another value of x1, that difference could be a different value. All right, hope you learned something today, and I'll see you next time.